Hey. We're going to take a look at this interesting and very simple topic called variation. We'll start with the concept map. So start with the introduction so that we understand what it is. Then we'll move to direct variation. After direct variation, we'll go into another type of variation called indirect variation. Then after that, we're going to combine the two types, direct and indirect variation, in what is called mixed variation. In this video, we're just going to take a look at introduction, direct variation, and indirect variation. There's another video for mixed variation. Of course, mixed variation is simple. Once you understand direct and indirect, mixed variation is simple. But in the other video, I've added just a demonstration of how questions sometimes are structured during exams. So, introduction. What is variation? Variation deals with how the change or varying in one or more quantity affects another quantity. So you may have two or three different quantities. One changes, it affects it affects the other quantities. So that's variation. The two quantities are connected. So if something happens to one, the other behaves in a certain way. So there are three types of variation. The first is called direct variation. In this, let's say you've got two quantities, y and x. So direct variation, what happens is if if x increases, y also increases. If x reduces, y also reduces. So whatever happens to x happens to y. So this knowledge is there to help you test your answers. When you're solving the variation questions, you can use this knowledge to test if what you have gotten is correct. So if x reduces, y also reduces. The second is indirect variation. In this case, let's say we have two quantities again, y and x, and let's say y is 0 and x has got a certain amount which we don't know. So what happens is if y increases, x reduces. So indirect variation is just when one thing increases, the other thing decreases, and vice versa. So if the opposite is true, if y reduces, x increases. So that's indirect variation. The third is called mixed variation. So in mixed variation, the two types of variations are mixed, direct variation and indirect variation. So let's start with direct variation. The statement y varies directly or proportionally to x mathematically is represented as y, this is read as varies directly to x. Y, this is read as varies. Y varies directly to x. So if y and x are like this, or if they say y varies directly to x, you have to write it like this. So what is this symbol? So this symbol, you have to replace it with equals, equal sign, and k. So you replace this with equal sign and k. So equal sign and k. That's how to deal with this. The question is, what is k? So k is called the variation constant or constant of variation. So like I've said, when y changes, x changes, but k does not change. So this relationship that is connecting y and x, k does not change, y and x will keep on changing. K can be represented by other letters, of course, depending on the way you want, but normally we use k to represent the constant of variation. So that's all about variation. You've got this relationship connecting y and x. K will be telling you what's the way the relationship is written, and the value of k will be telling you what will happen to the value of x when y changes, or what will happen to the value of y when x changes. So this is simple. Don't think too hard on it. This is very simple. So let's take a look at an example. Y varies directly to x when it's supposed to be when. Y varies directly to x when y is 6 and when x is 2. So y varies directly to x when y is 6 and when x is 2. Find 1 constant of variation, 2 expression connecting y and x, 3 value of y when x is 20, and 4 value of x when y is 1. So y varies directly to x, where y, also this is the question. The first question is find the constant of variation. So here's the solution. So the first job is you write this in mathematical expression. Y varies directly to x. So y varies directly to x. The symbol for variation, you replace it with equals k. It becomes like this. Once you do this, you can plug in the values that you have been given, because we are looking for a constant of variation, which is k. So we have been given y, which is 6, and x, which is 2. So always, for you to get k, you need the value at least the given value of y and x. So we've been given y and we've been given x here. So we substitute. Remember substitution in algebra. So where there's y, we put 6, and where there's x is equal, we put 2. So like I said, we've been given y, 6, and x 2. So we substitute. So y becomes 6, x becomes 2. So when you do this, take note here. When two variables are connected in algebra, we learn that in between there is multiplication. So this symbol here, it can also be used as for multiplication. So to write multiplication, you might it's a bit time wasting. So writing this suffice. So just instead of putting multiplication, but you can put this. It means multiplication also. So once you have this, you can divide both sides by 2. And we're going to have 2 cancelling here. So 2 and 2 are going to cancel. And 6 divided by 2 is going to be 3, which means 3 is equal to k, or k is equal to 3. The second question is expression connecting y and x. So expression connecting y and x is simple. What you do is we have this already, and what is important is where there's k, you put back the value that you have found for k. That's what you do. What have we found for k? We found k to be 3. So we put 3 where k is. We substitute here. So we have y equal to 3x. This is the answer. This is the expression connecting y and x. So whenever they say find the relationship between y and x, or the expression connecting y and x, this is what to do. Where there's k, you find the value of k. Then where there's k, you put the value that you have found. The third is value of y when x is 20. So again, this is simple. You just write your relation, which is y is equal to 3x, and they have said value of y when x is 20. So x has changed. Initially it was 2, now it's 20. So if x has changed to 20, what is y? So x is equal to 20. So what you do is y is equal to 3x. While there's x, you put 20. It becomes y is equal to 3 times 20, which is 60. So x has changed to 20. So where there's x, you put 20, and y has become 60. So this is this relationship connecting y and x, the one that you're going to be using to get all the answers. The other question is value of x when y is 1. So this time y has changed to 1. What is x? So again, the relationship and y is equal to 1. So the relationship here, where there is y, you put 1. So we can divide both sides by 3. We're going to have this. So if we divide both sides by 3, we have this. And here, the 3's are going to cancel. And we're going to have 1 over 3 equals to x, or just x is equal to 1 over 3 as the value of x. Simple. So the next example, which I'm emphasizing because of the language, is this: y is proportional to the square of x when y is 9 and x is 3. So find the constant of variation. So I want you to consider on the word square of x. If you remember in this, as I said, square of x or square of 2 is 4, square of 4 is 16. So square of x means x squared. So we write this expression: y is proportional to the square of x, y is proportional to the square of x. Square of x means x squared. If they say cube of x, it means x power 3. So the proportion is going to be replaced by equals k, which we're going to have this. Then after that, we're going to use the values that have been given to find the value of k. So we're going just to substitute, and solving for k, we're going to have 1. The statement, the second one is indirect variation. The statement y varies indirectly or not proportional to x can be represented mathematically as y varies inversely over x. So 1 over x means inversely to x. So of course the proportion can be replaced by equals k. We're going to have this equals k. So k can multiply by 1 we have k, and this k has an invisible 1 as a denominator. 1 times x is x. So in short, y varies inversely or indirectly can be written as y is equal to k over x. So example, y varies indirect to x, where y is 6 when x is 2. Find constant of variation expression connecting y and x, value of y when x is 20 and value of x when y is 1. So the first is constant of variation. So again, y varies indirectly to x, so y varies indirectly to x is this, which is just the same as this, like I showed. So where there's y, we put 6, and where there's x, we put 2 to find k. When we do that, we get k is equal to 12. So this part I'm going to skip, I've already done it. Expression connecting y and x. So y is equal to kx. We have found k being 12. So where there's k, we're going to put 12, we get the expression. Value of y when x is 20. So here, where there is x, we put 20. We get the value of y because x has changed to 20. So what's the value of y? So when we do that, we're going to have this, and reducing those terms is going to be 3 over 4. 3 over 4 is just like 0.75. This is inverse variation. X has changed from 2 to 20. So y has to reduce. Y has reduced from 6 to 0.75, which is 3 over 4. That's one value of x when y is 1. So y is equal to 12 over x. So where there's x, we're looking for value of x when y is 1. So y has changed from 6 to 1. What about x? So we expect x to increase. Since y has reduced from 6 to 1, we expect x to increase from 2 to something. Anyway, so where there's y, we put 1. When we do that, we're going to have this. So 1, of course, a number is over 1. We can do cross multiply. We're going to have x is equal to 12. So x has increased to 12. So this marks the end of this first part. Check out for part 2.